You're sitting in a car waiting to go. The driver's foot presses down on a pedal, and with a soft rumble, the entire 2-ton machine begins to move, gliding down the road. Have you ever stopped to wonder how that actually works? How does pressing a small pedal with your foot unleash enough power to move a car and you from one place to another? Cars are such a normal part of our lives that we barely think about them. We see them on every street in every city around the world. We know the wheels turn to make the car go forward, and the steering wheel turns the car left or right. But the real secret, the heart of the car, is hidden away under the hood. Inside that metal box is the engine. It's a masterpiece of engineering that solves a very tricky problem. How do you take a liquid fuel like gasoline and turn it into the powerful force needed to spin wheels and push a heavy car down the highway? The answer is surprisingly simple and a little bit violent. You create a series of tiny, controlled explosions. That's right. A car engine is essentially a machine that harnesses the power of thousands of explosions per minute, all happening in a safe and contained way. Let's zoom in and see how it's done. The main event happens inside several hollow tubes in the engine called cylinders. Inside each cylinder is a solid metal plug called a piston, which can move up and down. This simple up and down movement is the key to everything. Suck, squeeze, bang, and blow. Let's start with the first stroke. Suck, or more technically the intake stroke. The piston starts at the top of the cylinder and moves downward. As it moves, it creates a vacuum, like when you pull back the plunger on a syringe. A tiny door, called an intake valve, opens up. The vacuum sucks in a mixture of air from the outside and a fine mist of gasoline from the car's fuel system. By the time the piston reaches the bottom, the cylinder is filled with this flammable air-fuel mix. That's step 1 complete. Squeeze. This is the compression stroke. The intake valve closes, sealing the cylinder. The piston then reverses direction and starts moving back upward. As it moves up, it squeezes the air and fuel mixture into a much smaller space. Why squeeze it? Think about a popped balloon versus a firecracker. Compressing a fuel makes its eventual explosion much more powerful and concentrated. So now we have a highly compressed, highly energetic mixture trapped at the top of the cylinder. Bang! This is the combustion or power stroke. At the very top of the cylinder is a small but crucial part called a spark plug. Just as the piston reaches the peak of its upward motion, the spark plug creates a tiny, precisely timed bolt of electricity, a spark. That spark instantly ignites the compressed air-fuel mixture. The result isn't a slow burn. It's a powerful, instantaneous explosion. The incredible force of this explosion blasts the piston back down the cylinder with tremendous speed and power. This downward push is the single moment of useful energy created in the whole cycle. It's the bang that will eventually make the car move. But the job isn't done. The cylinder is now filled with burnt gases, basically smoke and exhaust. We need to get rid of it to make room for the next cycle. Blow. This is the exhaust stroke. At the bottom of the power stroke, another door, the exhaust valve, opens up. Piston travels back up the cylinder one last time. This time, it acts like a plunger, pushing all the used, smoky gases out through the exhaust valve. These gases travel through the car's exhaust system and out the tailpipe at the back of the car. Once the piston reaches the top, the exhaust valve closes, the intake valve opens, and the entire 4-step process begins all over again. Suck, squeeze, bang, blow. This cycle repeats over and over, incredibly fast. In a car that's just idling, this can happen over 1,000 times every minute. At highway speeds, it can be happening 3,000 or 4,000 times a minute. Most cars don't have just one cylinder and piston. They usually have 4, 6, or even 8 of them, all working side by side. They are timed perfectly so that they don't all bang at once. While one piston is on its power stroke, another is on its intake stroke, and another is on its exhaust stroke. This teamwork creates a smooth, continuous flow of power instead of a jerky, pulsing one. So we have all these pistons moving up and down, but a car's wheels need to go round and round. How do we convert that motion? The answer is a brilliant piece of engineering called the crankshaft. Each piston is connected to a special rotating shaft at the bottom of the engine. As the pistons are forced up and down, they push and pull on the crankshaft, forcing it to spin. It works just like your legs on a bicycle. Your knees move up and down, but they push on pedals that make a crank spin in a circle. The pistons are your knees, and the crankshaft is the bike's crank. This spinning motion from the crankshaft is the rotational power that the rest of the car can use. That power is sent to the transmission, which is a set of gears that helps control the speed and power, and from there, it travels down axles to finally turn the wheels. So when a driver presses the gas pedal, they are telling the engine to let in a little more air and fuel for each cycle. More fuel means bigger bangs. Bigger bangs push the pistons down harder, which spins the crankshaft faster, which turns the wheels faster, and makes the car accelerate. So the next time you ride in a car, remember the incredible, invisible science happening under the hood. Every journey is powered by a perfectly timed symphony of tiny controlled explosions, turning a simple liquid into the magic of motion.